Welcome to my channel Phi Concepts CHM. This is the third part of the series of band theory of solids. Here we will see the conclusions of Kronig Penney model. We had derived the equation in the previous video. P sin alpha A upon alpha A plus cos alpha A is equal to cos Ka, where P is equal to mv0 AB upon h cross square. So we will plot a graph of P sin alpha A upon alpha A plus cos alpha A, this is the LHS part, versus alpha A. So we get this graph with the allowed regions showed in the shaded part and the forbidden regions in between the allowed bands. So we'll see the conclusions. First is the allowed energy bands. The shaded part is separated by the forbidden energy bands. As alpha A increases, the width of the allowed bands increases and the width of the forbidden bands decreases. If P is large, that is, it crosses the limits +1 and -1, that is, it is steep. The allowed bands will become narrower and the forbidden bands become wider. In the limit of P tending to infinity, the allowed bands reduces to a single energy level. That is, we'll get a discrete energy spectrum of isolated atoms. So as P tends to infinity, sin alpha A is equal to 0 for the values of alpha A is equal to plus minus n pi. We can find alpha from here as plus minus n pi by A, and then we can square it so that we will get alpha square is equal to n square pi square upon A square. Equation A. From equation 4, which we had seen in the previous video, that is alpha square is equal to 8 pi square me upon h square, and we are substituting here h cross. This is 2me upon h cross square is equation B. So equating equation A and B, we get n square pi square upon A square is equal to 2me upon h cross square. Therefore, E is equal to n square pi square upon A square into h cross square upon 2m. In place of h cross, you can substitute h by 2 pi. So this pi will cancel out and pi square will cancel out. So what we get is E is equal to n square h square upon 8ma square. Equation 15. E is independent of k and P tending to infinity means an infinite potential well, which represents tight binding. Large P indicates tunneling through the barrier becomes almost improbable. Now for P tending to 0, from equation 14, P sin alpha A upon alpha A plus cos alpha A is equal to cos Ka. This is equation 14. So P tends to 0. So what it reduces to cos alpha A is equal to cos Ka. So alpha A is equal to Ka and hence alpha is equal to K. You can square this so that alpha square is equal to K square. Also from equation 4, we know alpha square is equal to 8 pi square me upon h square is equal to 2 me upon h cross square. So you consider this equation, alpha square is equal to 2 me upon h cross square. Rearrange that equation, you get E, so that will be h cross square alpha square upon 2m, and in place of alpha square you can substitute k square, so h cross square k square upon 2m. So now as k is equal to 2 pi by lambda, we can substitute that in place of k, so that is 2 pi by lambda the whole square. Also lambda is h by p, so we have substituted lambda, 1 by lambda as p by h. Solving this, we get p square by 2m. Also p is equal to m into v. Substituting that, we get E is equal to half mv square, equation 16. So equation 16 is for completely free particles. Here no energy levels exist. So that is shown in this diagram. Equation 16 is this, represents this, where there are no energy levels existing. The intermediate case is this, where there are allowed bands separated by the forbidden bands, and this is for P tending to infinity, representing tight binding, that is the bands reduced to single energy levels. So equation 16 represents that all energies are allowed, which is the classical theory. So from the Kronig Penney model, we get the complete band structure by varying P from 0, which represents the completely free electrons, to infinity, which represents the completely bound electron. Thank you for watching my video.